Hello, this video is for IXL Activity 8.W.14. Solve equations, word problems. The three-character code for this is Hotel Charlie Papa. Now, word problems usually make math students freak out. They absolutely hate word problems. The key to word problems is to read it, understand what operations you need to use, and understand what values that they give you and try to pull the stuff out of a word problem and then turn it into a mathematical sentence using the proper numbers and the proper operations in order to arrive at the correct answer. So we'll go ahead and we'll look at that. In here, there's some one-step equations and some two-step equations. It does not get beyond two-step equations, and this does relate to the two-step equation activities that we've been working on. So we're pretty much jumping out. 8.W.8 was about two-step equations, and now we're still doing some two-step equations. It's just that we're doing it in word problems. We're going to have to translate those word problems over to an equation so that we can then solve it to get the answer. So with that, we'll go ahead and start off. Ling can grow 3 flowers with every seed packet. How many seed packets does Ling need to have a total of 18 flowers in her garden? So the word per is an interesting word, P-E-R. Per tells us to multiply, M-U-L-T. I'll just use M-U-L-T for multiply. If we can find a way to use the word per, like feet per minute or weeks or hours per week or something like that, that's a good indicator that we need to multiply. Now, we don't see the word per in here anywhere, but we probably could insert it someplace and it would still make sense. So Ling can grow 3 flowers with every seed packet. Another way to say this would be 3 flowers per packet, right? P-K-E-T. So if we just rephrase this as 3 per packet, this would be 3, we pull that out as 3 times P, 3 times each packet for every one packet. Or we could also just call that 3P, right? And because 3 flowers for every packet. And 3P means 3 times P, and here we have 3 per packet, or 3 times P, P for packet. So now the next question is, how many seed packets does Ling need to have a total of 18 flowers in her garden? So we know that for every pack she gets 3 of them, but we're wanting to know about what if she wants 18 of them, right? So now we need to solve for P. So whenever we look at this, we realize that for every packet, we're going to get 3 flowers, and we want to know how many packets do we need to get 18. Well, like we've been doing in solving one-step equations, this 3 is tied to the P through multiplication. The opposite operation is division. We're going to divide by the very number we wish to get rid of, which is 3. And what we do to one side, we're going to do to the other. We know that the 3's cancel each other, and we end up with P. And 18 divided by 3 is 6. So it would be 6 seed packets. And we could look at this and think through the problem. Does that make sense? And so in order to have 18 flowers, well, if we had one packet, that would be 3 flowers. 2 packets would give us 6. 3 packets would give us 9. 4 packets would give us, 12. 5 packets would give us 15. And 6 packets, indeed, would give us 18 flowers. So it does seem to make sense. And always checking to see if your answers make sense in a word problem is usually a pretty good idea. Looking at our next problem here, and notice that the word per is already here for us. Good deal. So Carla's auto wash earns revenues of $9 per customer. So we could say 9, and I still got the P from packet stuck in my head. So we have $9 per customer. So we could say 9 times C, or if we want to just do that as 9C would be good. So Carla's auto wash earns revenues of $9 per customer. In all, how many customers does Carla's auto wash need to serve in order to have a total of $36 in revenue? So how many customers, it says how many customers, and notice that is the unknown, so that's the variable we're trying to solve for. So we have $9 for each customer, or per customer, right? For each is another good clue that we need to multiply. We want to know whenever this 9C, or $9 per customer, we want to know when is it going to equal $36. So now we have a one-step equation of 9C equals 36. Let's go ahead and solve that. The 9 is tied to the C through multiplication. The opposite operation is division. We're going to divide by the very number we wish to get rid of, and what we do to one side, we're going to do to the other. The 9's will cancel each other, leaving us with C, and 36 divided by 9 is indeed 4, correct? Yes. So C equals 4, and that would make sense. 2 customers would give her $18, 3 customers would be $27, and 4 customers would be $36. So it does seem to make sense. Now we're going to get into something added on to here. So we're going to now have a two-step equation. And we see that Mabel already, this is a key word already. I'll come back to it though. But Mabel already knew three appetizer recipes before starting culinary school. And she will learn one new recipe during each week per school. Or way of looking at that is one per week, right? So 1W, one recipe per week. And she already knows 3, so she's starting off with 3 already. See where the two-step equation's coming in? And we want to know at what point will she know how many weeks, right? It says that how many weeks, so the W here is good. And we got this W from 1 per week, right? Right there. So, and she already knows 3, so we want to know when will she know 46. So at this point here, we probably could simplify this. 1 times W is just going to be W. Bring down our plus 3 equals 46. So now, technically we only have a one-step equation, but if this were more than just 1 per week, we'd end up with a two-step equation. However, actually we did one step already, and that was to multiply 1 times W to simplify this to W plus 3 equals 46. So with that said, let's go ahead and solve this. The 3 is tied to the W through addition. Let's use subtraction to undo that. And we're going to subtract the very number we wish to get rid of. And what we do to one side, we're going to do to the other. And so we end up with just W here because the 3's cancel each other. And 46 minus 3 is 43. No division going on here. So it's 43 weeks. And that makes sense, right? In 43 weeks, if she learns 1 per week, she'll know 43 of them 43 weeks from now, but she already knew 3, so that would be a total of 46. Jeremiah has already spent 4 minutes on the phone, and he expects to spend 1 more minute with every phone call, or 1 minute per phone call. So we could say 1 per phone call. Let's do, I guess, we'll just use P for phone calls, right? But he's already spent 4 minutes, so plus 4. And we want to know how many, at what point will you have 47 total minutes? So we end up with 1 times P plus 4 equals 47. So I got the 1P for 1 more minute, 1 minute for every or per phone call that he routes. So that's where I get the 1P. He already had 4, so we're going to add 4 on there because he already had that. And then we want to know when is it going to equal 47. Well, we could simplify 1 times P is P, plus 4 equals 47. Let's go ahead and subtract 4 from each side, right? Undo the addition with subtraction. These will cancel each other, leaving us with the P, and 47 minus 4 is 43. So it will be 43 phone calls. And what is that, 2 43s in a row? Yep, 43 weeks, 43 phone calls. On the next one, Marco already, so there's a starting amount, right? Already knew 31 appetizer recipes, so that's probably going to be a plus 31. Already starting with 31. Before he started culinary school. And he will learn 4 new recipes during each week, or per week, right? We could call this per week right here. And so we know that that is 4 times W, 4W, right? And he already started with 31, plus 31. And we want to know when's he going to have a total of 47, so that equals 47. So now we have a two-step equation. Before we deal with the 4W, we need to deal with the plus 31. So let's go ahead and subtract 31. And what we do to one side, let's go ahead and do to the other. The positive and negative 31 is going to cancel each other, leaving us with 4W. And 47 minus 31, well, 7 minus 1 is 6. And 4 minus 3 is 1, so we have 16. The difference is 16. Now, let's go ahead and divide, because the 4 is tied to the W through multiplication. The opposite operation is division, and we're going to divide by the very number we wish to get rid of. And what we do to one side, we're going to do to the other. The 4's will cancel each other, leaving us with W, and 16 divided by 4 is indeed 4. So the answer is it would be 4 weeks. 4 more weeks at culinary school before he knows 47 appetizer recipes. Okay, moving along to the next one. Marco's hair was 4 centimeters long after his last haircut, and it grows 15 centimeters every year. How many years will it take until Marco's hair is 34 centimeters long? So here's our total right here, right? So this is going to be the equal 34, right? We know that's going to be the total we're looking for. Do we have a starting amount? Well, they say that his hair was 4 centimeters after his last haircut, right? So we know that he's not bald. He already has plus 4, right? Plus 4 centimeters. So we'll put our plus 4 there. And now, what about the rest of it? Well, we know that it grows 15 centimeters every year. Or another way of saying this is 15 centimeters per year. Or another way to look at this is 15 times 1, 15 centimeters per year. Or, and we want to know years. Years is the unknown. So actually I should put 15 per year, per 1 year. Or we could just use Y for years. So let's do that. We'll call that 15Y. So he gets 15 centimeters per year. So we have 15Y. It's already 4 centimeters long. At what point will it equal 34 centimeters? So let's go ahead and subtract 4 to get rid of that positive 4. And what we do to one side, let's do that to the other. The 4 is going to cancel each other, leaving us with 15Y. And 34 minus 4 is going to be 30. Now we have the 15 tied to the Y through multiplication. The opposite operation is division. We're going to divide by 15 because that's what we wish to get rid of. And what we do to one side, we're going to do to the other. 15s are going to cancel each other, leaving us with Y. And 30 divided by 15 is 2. So it's going to take 2 years before Marco's hair is 34 centimeters long. The cost to rent a moving van is $6.54 plus an additional $11.40 per hour. For $29.34, what is the maximum amount of time that a moving van can be rented for? So if we look for our total, we should hopefully spot that this is going to be our total. We're going to have an equals 29.34. And yes, we're dealing with decimal numbers, aren't we? Then there is the question of, are we starting with anything? Is there a starting amount? Well, whenever you rent a moving van, it costs this plus this per hour. There's that word per. So we know that we have 1140 times, right, multiplication hour. So we'll just call it H for hours. And H is what we need to know. So this works out really well that we have the 11.40, right, 11.4. I'll just do 11.4. It's money. Let's go ahead and throw the 0 in there. And we'll call that hours. But we also have to add to that the initial cost of just renting it. No matter how many hours we rent it for, we still owe $6.54. So we now have this equation here, and I think I'm going to go ahead and use my calculator instead of filling up the screen with that. The idea is to learn the process. Hopefully we know how to add and subtract decimals already. So I need to get rid of this positive 6.54. So I'm going to subtract 6.54 from each side. Right, what we do to one side, we need to do to the other. And whenever I do that, I know these are going to cancel each other out. So I'm going to end up with 1140H equals, and 29 clear. I'm just going to clear all that out. 29.34 minus the $6.54 is going to give us $22.8. And since we're dealing with money, I'll go ahead and leave that 0 on there. Now the 11.4 is tied to the H through multiplication. The opposite operation is division. I'm going to divide by the very value I wish to get rid of. And what I do to one side, I'm going to do to the other. we know the 11.4s will cancel each other out, leaving us with just H. And then we have 22.8, and we're going to divide that by 11.4, and we're going to get the answer is 2. So it would be 2 hours. You can rent a van for 2 hours and have a total of $29.34. On the next one, Olivia has already prepared. So here's our already prepared this. So that's probably going to be a plus 13.5, right? We have a starting amount. So she's already prepared this amount of dough. And she will continue preparing 6.59 kilograms of dough every hour, or per hour, right? So we could say this is 6.59 per hour, so times each hour, which is good because we're being asked for hours. How many hours did Olivia work if she prepared 59.63 kilograms of dough? This is going to be our total right here, right? This is what we want to know in all, so that's what equals 59.63. We do have a rate of 5.59 kilograms, right? Kilograms, yep, per hour. So we're going to have that 6.59 H. And we already have a starting amount of 13.5. So we now have a two-step equation. So let's go ahead and deal with the positive 13.5 by subtracting 13.5 from each side. And what we do to one side, we're going to do to the other. Throw that 0 in there. Now these will cancel each other out, leaving us with the 6.59 H equals, and let's do that 59.63, and we're going to subtract from that 13.5, and that's going to give us 46.13. And now we need to go ahead and divide both sides by the 6.59, because the 6.59 is tied to the H through multiplication. The opposite operation is division, and we want to divide by the very number that we wish to get rid of. And what we do to one side, we are going to do to the other. We know that these 6.59s will cancel each other, leaving us with H. And then 46.13 divided by 6.59 is going to give us a solution of 7. So 7 hours is our answer. All right, let's look at our next one. Members only speaker series allows people to join for this much. So you join the club for that much. So if you're going to join, you got to pay this up front. So that's a starting amount, right? So that's plus 58.94. That is our starting amount. And then you pay $11.01 for every event attended, or look at it this way, $11.01 per event. So we'll use E for event. So we could have 11.01 E, right? Because that's what we're paying per event. This is our rate right there. What is the maximum number of events someone can attend for a total cost of $91.97? So 91.97 is going to be our total. We're already starting with this, and we know that for every event that we're going to have $11.01. So that's $11.01 per event. So we'll have 11.01 E, and then we're going to add to it the starting amount, what it cost to join the club in the first place, 58.94. Now we have a two-step equation. We can go ahead and start solving. So let's go ahead and get rid of this positive 58.94 by subtracting 58.94. And what we do to one side, we need to do to the other. So we'll subtract that. These will cancel each other, the 58.94s. They are opposites of one another, so they produce a value of 0. And 0 plus 11.01 E is still 11.01 E. And that equals... it's the word whole, I guess. So, it couldn't help it. And 91.97 minus the 58.94 is going to give us a difference of, this will work out real nice, 33.03. And I'm not even going to need the calculator for this one. The 11 8.01 is tied to the E through multiplication. The opposite operation is division, and we're going to divide by the very number we wish to get rid of, which is 11.01. And what we do to one side, we're going to do to the other. And so the 11.01s are going to cancel each other, leaving us with just E. And this over here, 33.03 divided by 11.01, is going to give us an answer of 3. So E equals 3. It would be 3 events. The key here is to recognize what is your starting amount. Also, what about a rate like this, how much per something? Realize whatever it's per is usually what's looking for in your answer, and that's where your variable is going to come in at. And then you're going to set it equal to whatever they're asking for a total cost. You're going to realize that there's a total someplace. Once you get that, you can then set it up into a mathematical sentence, translating from the word problem over to a math sentence, understanding which numbers do you need, which operations do you need to use, and then once you know that, then you can go ahead, set up the math sentence, and then through the algebra, solve for the final answer. So those are all of my examples for IXL 8.W.14, solve equations within word problems. Good luck in your activity.